Teaching a machine to survive in hostile space, coming up on Machine Learning Basics. Alright, so when I was young, I was using my dad's IBM PC XT8086, old school computer, 1984-ish or so. And I remember there was a game on there that I really liked that was basically a space battle game. You had two spaceships duking it out in open space. You got to fly around, you could turn left, you could turn right, you could shoot, and you could move forward, and that's about all you could do. And it was a very simple game, but my brother and I had a lot of fun playing that game, and I thought that that would be a really good subject to be looking at for building our next game project. So what you're seeing is the output of more than a little bit of training on a similar kind of environment. So in this case, I wanted to focus on just navigating and surviving in a hostile environment. So you'll see there's a spacecraft, there's 6 blue bullets of some kind, and the spacecraft wants to dodge the bullets as long as it possibly can. You hit the top of the screen, you wrap around to the bottom, left goes to the right, that kind of thing. And everything is really randomized, right? And so in a lot of cases, the game starts off and you'll have a bullet aimed right, very close to the ship, aimed right at you. Oh yeah, everything is randomized, except that the bullets are always aimed at the start position of the rocket. So you have to move, right? You can't just sit there. But in some cases, since there's 6 bullets, and you can only turn so quick, sometimes you can't escape, and so you blow up at the very start of this game. It's a very challenging game. It didn't start out that way, so I'm going to go through the code, and I'm going to go through some of the things that I did. This scene is a nice finished demo scene. I have the particle effects for when the player hits the thrust. It's a nice visualization, and we've got some bloom going on the blaster beams, that kind of thing. But we're going to go back to the training and the code and see how this is all put together, beginning to end. So that's my demo scene. I'm going to go to my Stay Alive game, and as always, this is going to go up onto SourceForge so that people can see it. I have 24 instances of it, 23 of which are turned off, but this is essentially a 2-dimensional game, so you can just see I have a bunch of them there to help parallelize the training. In each game, let's say I only have 1 camera, 1 directional light, and 1 academy. The academy in this case is my generic academy. It really doesn't do anything, so all of the interesting code is in the environment itself. Yes, so here's my super fancy academy that all fits in 1 screenshot. All right, so let's go ahead and hop into this environment, and I'm using the new Unity prefabs, nested prefab-y stuff, which I really enjoy. So the first thing that we have are the 4 walls, bottom, top, left, and right. And these have simple triggers on them, and this teleport script so that when something hits the top wall, it just gets teleported to the bottom. It retains its velocity and everything else. It just poof goes from one to the other. With a little bit of a buffer so that if it can't sit on the border and teleport back and forth between the two. Let's see here. The ship that I trained with was this very simple sphere, and I just put another blip of a sphere on the front of it so that I knew which way was forward. And then after that, I have 6 bullets. And so we have 6 instances of the bullet. And so that's kind of like a game maximum, right? Each player maybe only gets 3 bullets on screen at once. And in this case, we have 6 bullets in total. The bullets aren't anything special. They have render. I have an unlit material that I've applied to them, and their rigid body is frozen in certain constraints, right? It can't move in the Z-plane, and it doesn't actually rotate. It just gets a velocity and goes in a certain direction. All right, so then we're going to get to the ship, right? That's the main part of it. Oh, and the game, right? So this environment overall, it has a player, which is the ship, and then an array of 6 bullets. So the ship has all the code, though. The mesh renderer does exactly what you expect. And then we have our ship agent. So this is the one where we're going to go through and see what all of the code here is and does. All right. So first of all, it just has a pointer to its own environment. I give it a turn speed. I have these kind of tweakable. You want it so that people can play your game. I ended up with the speed of, I believe it was 3 degrees, and then an acceleration speed of 10. So those are there. This is, again, the reward for surviving 1 frame. So when I was training, basically I said you get a reward for surviving until the next frame, and then there's a pretty significant penalty if you get destroyed. And then this is also how many bullets are there in the world, and we need to adjust our observations accordingly. This is one of the main challenges with machine learning agents, is it's not flexible to the number of inputs, right? You get a set number of inputs, you train a network on that number of inputs. And it might work okay with fewer, but it doesn't recognize more inputs than it's given. So you can't just have an adjustable array of bullets. You basically have to set a hard limit somewhere, which is why I just said 6. This aim at player equals false, so I'm going to talk about how I trained this. You'll see that I iterated over this probably a dozen times or so before I got some of the behaviors that I liked. And this aim at player was actually the big key one to getting it to work the way I wanted. Let's see, a pointer to its own rigid body, references to the bullet rigid bodies, and then also an optional particle system, and this is just for that little animation to visualize when it's hitting the thrust button. So again, when it starts up, it looks for that particle system. If it doesn't find it, that's fine. All of the references to that particle should be in null checks, so they should be good to go. Same thing with a rigid body. Actually, it'll error out if it can't find a rigid body for the ship. This simulation does rely heavily on the Unity physics engine, so it's using rigid bodies a lot. And so if things don't have rigid bodies where you expect them, it's going to give you some errors. And then for each of the bullets, it's also looking for a rigid body. So it needs to know the rigid body for the ship, the player ship, and then any and all bullets in the scene, because I'm going to have in the final game, it doesn't matter if it's your bullet or your opponent's bullet. If you get hit by a bullet, you blow up. Because that's how the game in the 80s worked. Vector observations. So in this case, it's pretty straightforward. What is the ship's position, right, in the X, and the ship's position in the Y? And again, we're adjusting for the environment position, because as we saw, we had a whole bunch of them stacked. Now, they were all on 0, 0, the origin, but you know, if you bump one and move it up or down or something, you want to be giving it consistent coordinates that are relative to that environment, because otherwise it's going to have to learn a whole bunch of different absolute coordinate systems. So having positions relative to your environment is super valuable for having stable and useful observations. And then also the only rotation it does is the z-angle, the Euler angle, on the z-axis. And so we provide that as well. So the x and y position and the z rotation. In addition, we have the x and y velocities and the z angular velocity. So how quickly is it moving in the x and the y and the z. Again, this is a space game. There's no friction. There's no drag. There's none of that. And so once you get moving in a direction, you are moving in that direction. If you want to stop, you have to turn 180 and then accelerate in the negative direction. Similarly, for each bullet in the 6 bullets, it is going out and it's getting the relative x and y positions and the relative x and y velocities. In the case of the bullets, we don't worry about orientation because they're bullets, not missiles. On collision entered. in this case, I just use the ball tag. So each one of the bullets has the tag for ball. And so if the spaceship enters a collision and it collides with a ball, then we give it the reward of, in this case, a negative reward of being destroyed, and then we tell the simulation you're done. Otherwise, I trained it with, I believe it was a 200 step maximum. So it would go up to 200 steps. And so surviving all 200 of those steps got the maximum reward. That's what yields a maximum reward. So this is all in discrete space. So it's been a little while since we actually have done something in discrete space. I do really like some of the features they've added to ML agents, where you have the branch size. And so in this case, the branch size says, or how many branches, right? That's how many families of operations, and then what is the size of each branch. So in this case, right, the first branch 0, right, is our thrust. So you're either hitting the thruster or you're not, right? You're either accelerating or you're not. And so branch 0 has a size of 2, off or on. And then branch 1, right, the second branch, that's the turn branch. And so that's going to be left, right, or no turn, right? Or so I put it in as none left and right. So you'll see that we do this floor to int for vector action 0 and vector action 1 for thrust and turn. If there is a particle system, then this is where we say, hey, particle system, emit or don't emit based on whether or not we are using our thruster. If we are thrusting, then we are adding a force, and we're, in this case, the right, because in Unity forward would be into the screen, and this is a two-dimensional thing, right? So our right would be positive x, and so that would be our forward, and so we're taking the local transformed right and then adding the acceleration speed if we are thrusting. If we are turning with a value of 1, then that's positive, and then if it's a value of 2, it's a negative, and if it's anything else, we just ignore it. So again, we're just adding to the angular velocity of the rigid body. And since we've made it to the agent action stage, it gets a very small reward for surviving another frame. And then let's see here. Agent reset. So when the game resets, so at the very first time or any time that the ship blows up and the game is done, we zero out the velocities of the ship. We find a new position for the ship. And then for each of the bullets, we zero out their current velocities. We get a randomized position, and then if we're aiming at the player, then we calculate the direction toward the player, and we give it a random bullet velocity. And then if they're not aimed at the player, we just give it a random direction, and once again, a random velocity between 2 and 10. So some bullets are slow, some bullets are fast in this case. But the idea is, in one scenario, we're aiming at the player, and the other one we're not. And I started with not aiming at the player, and I'm going to show you why that turned out to not be a super awesome idea. Okay, so here's our world. And you've seen how it does. It does pretty good. I do see some behaviors that I think it could improve. For example, sometimes it will dodge things very much at the beginning of the game, but then as it's going, the ships will sometimes actually speed up and fly forward into a bullet. They'll actually catch up with a bullet, and that's very often how they get destroyed. And so I figure once it solves that problem, I think a little more training will do it. Oh, yep, see there, it just flew into a bullet. Once it learns better than to do that, should be good. The other thing, there's a number of things I think could improve this, and so for the next iteration of it we'll do is that the bullets only last a little while, and then I'm going to add another ship. So what this provides is now we have a ship to shoot at, right? We have bullets to dodge, and we have an opponent ship to shoot at that doesn't want to get hit, adding some challenge. So, right, let's take a look at the training. So as I said, I did a whole bunch of training runs for this. This was the most successful was training run 12. So part of it was that this was very complex behavior. This is a very challenging environment as well. One of the things I started with, though, was just one bullet. And so that wasn't hard enough. And what was happening was that with only one bullet, it wasn't really coming up with a good policy because very often the bullet wasn't anywhere near the ship, and so it wasn't doing anything. It was kind of a boring game. So I added more bullets and made it harder. But at the same time, when I added more bullets, I still randomly chose a position and direction for the bullet. And what that meant was that a lot of the time, the bullets were not aimed at the ship. They were just off doing their own thing. And so we ended up with cases where, the variance in the training and the values of the training is huge, right? And we start with a 1.15, and so a maximum score for this environment is, I think I did 200 steps, so it was 2, right? With a 0.01 reward for each step along the way. And so what we're seeing is the fact that a lot of these, the ship doesn't even have to move in order to do well. They can just sit there and not do a lot, and the bolts just whiz by, and it'll get a good score. And it hasn't actually learned anything, right? It just knows that if it sits there, everything's going to be just fine. So as I was monkeying with it, because the other thing is I'm looking at this, and I was like, I can't even tell if it's actually learning anything or doing anything, even when I really crank up the smoothing. You can see, all right, maybe it's learning a little bit, but there's still, that's fully smooth. It's really hard to know if it's actually learning a bit. And it did. It did learn some. And I can show you the two different brains. It did learn some, but it is hard to tell. And this was over 6 million iterations. So I took the exact same problem, and I said, I actually want to make it harder, because making it harder forces the player to do something. When the bullets are aimed right at you, that you have to take action, because otherwise your game's going to be super short and your rewards are going to be garbage, and so your scores are going to be really low. You can't just sit around and float around lazily and get lucky and get missed. And so when I did that, this is the graph that I got out of it. Now, that is really, really encouraging. Right? Now, when you compare the two graphs, you say, hold on, this one is, these scores are way higher. And again, that's because the game isn't actively trying to kill the player, right? So by aiming the bullets at the player, this blue is in a much harder game. And so we got a curve that really showed that it actually learned something. So it's much more visible, the progress that it was able to make. I can also tell, based on this curve and based on some of the behaviors I've observed, that it's not done learning. I think that there could be much more that it could do. This is 6 million, so on my new machine, that's, I can see the numbers right there, 12 hours. And that's very, very fast compared to the old machine that I had a month and a half ago. So, with only 12 hours of training, we were able to get it to the point where it is near or superior to human players, and I think we could train it to be really super duper powerful. Let's see here. Oh, so let's go back and we can also show, I did keep the other brain, so I have the easy mode and hard mode, because... And let's see, I'm going to open this up in the demo scene so that we can kind of do comparison, one after the other. So this is, again, the one that's trained in the hard mode, and all those bullets are swimming at it, and it was able to dodge and get out of there just fine. Now, if we also go to the environment and go to the ship and say aim at player, we can turn that off, right? This is one of the advantages of having things that are able to turn on and off. Start it back up again, and then we can just see that there's bullets wherever, and the bullets are clustering because I have rigid bodies on them, and normally they should pass through each other, and I noticed, and you know what, it's just not important enough for me to care at this point, although that is going to be something that I do fix later, is that bullets can't collide with themselves or each other. So that's one brain, and again, that's pretty good. And then we'll go, and this is the easy mode, so I'm going to go to the ship, just going to lock that, and then bring the easy mode behavior over, and then initialize the game. Here we go. So you'll see it acts very differently, right? It does avoid things, it does escape, but it's nowhere near as decisive, it's nowhere near as nimble. This is the same amount of training, and this is the easy environment that it was trained in. And so, yeah, I mean, it's learned something, and it doesn't get hit as much as it could. It also spends a lot of time and energy spinning aimlessly in the dark. Let's see here. But then as soon as I click aim at player, all of a sudden the one that's trained in the easy mode has a real challenging time in the hard mode, right? Like, big surprise. So it ends up blowing up a lot. Not as much as it could. Again, it has learned some stuff, and it keeps itself equidistant from things. And actually what I find interesting is it is far less likely to survive an initial encounter, but it is more likely to not fly into the bullets later. So we have kind of two flight mechanics that have different strengths, and I find that kind of stuff fascinating. And so we'll have to think about, is there a way that we can trade between or whatnot? Because once it's actually alive, it does pretty well. But again, one of the next things I'm going to be doing, I got it, is resetting the bullets after a few seconds. Like, the bullets fade out, and then a new bullet gets fired before I start having bot-on-bot trading battles. And so that's really where I'm going with this, is we're going to have two bots playing each other and trying to get better and better and better at the game. So that is where we are. It's a solid intro, solid demo. I have put a call out, so for my patrons, I put a poll out that says, hey, should I include, I added a model of a rocket. I just did this in Gravity Sketch myself and tossed it in here because I thought it would look a lot nicer, and it really does, as opposed to my training series. And part of the reason why I use simple shapes for training is just to help keep frame rates up, keep it computationally really efficient. I said, hey, patrons, do we want to make this, some of these art assets and stuff patron only, or are we keeping it free and open? We don't have all the votes in yet, so I'm not going to post that content on GitHub just yet, although I will say that it looks like the patron crew has said, no, just keep everything free and open. We'll see the final votes, and if you are one of my patrons over on Patreon, go ahead, look for that message, get our final votes in so I know what to do with these assets, so that I can get them committed to GitHub in the next day or two. Let's see, I think that's pretty much all I had. If you're finding value in these videos, please go ahead and hit the like button. If you've watched a couple of them and said, hey, wow, I found a few things that are really helpful, go ahead and hit subscribe. And then if you're really getting a lot of values out of these, or really engaged, or want to see, you want to participate in part of the direction of the show, feel free to check out my Patreon below. We have some very inexpensive entry tiers for a lot of folks. Anything else? Oh, so next steps. I want to improve the game. I'm going to do some iterations. The other thing that I'm going to do, and I'm going to do this a little more consistently, I think, is I don't love the code in here where I'm checking to see if I have a particle system or not, then I take an action, right? I feel like this is cluttering up the agent code. So one of the things I'm going to do on the next iteration of this is to take that and make it so that it's more modular and so that it's really calling out Unity events for visual effects. And so you'll have one blanket visual effect messages thing that you can turn on and off, so that when you're doing training you can be really efficient, but then when you want it to look really nice you'll turn it on and it'll send out messages to things like the particle system that says, hey, emit particles over time. So those are some of the kinds of things that I am looking forward to in the next iteration of this project. In the meantime, I think this should be a good fun one. The other thing that I haven't done yet in this that I need to do is make it so that it is human playable, and that is something that Unity's changed how they do that. It used to be that they had a player brain, a heuristic brain, and a training brain. Now they just have a heuristic brain and a learning brain, and so the idea is that having a user be able to play the game, they just consider that a heuristic, as live player input is a heuristic. So I'll put that in the next iteration as well. So those are a couple of to-dos for version 2 of the Space Battle game. All right, as usual, if you have any questions, thoughts, concerns, please feel free to drop them in the comments below, or if you're a Patreon patron, put them over on Patreon, and I will endeavor to get to them as quickly as I possibly can. Until then, good luck and happy learning.